All right, I'll be honest with you, this is one of the reasons I've been recording these videos, because I just think this is a hard question. And it's one that I think I notice that students struggle with, especially those of you who aren't happy with the maths that's going on here. Please, 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 when you're doing this question, remember there are marks here that you can get. Okay, there are some marks which are hard, I totally agree with that, and I think it's a little bit unfair, but we'll just go for it and we'll see what we can do. Okay, we're looking at data from the Stefan-Boltzmann law, okay, and we're looking at luminosity, Stefan-Boltzmann constant, radius, temperature, etc. We're going to verify the law by using values from databases, maybe something to do for an IA. All right. Now, first thing we do is we look at the table. It's got empty bits in there, and we need to work those empty bits out. Okay, so we've got Polaris B, and it's missing an L over R squared. You notice that all the other L over R squared values, even this one with 8.0, you attempt to call that an 8, is given to 3 significant figures. So your number must be given there too. All right, but we're expecting that your value lies somewhere between these, because if you notice we've got a descending magnitude, we expect something in the region there. So I've gone and calculated it. L over R squared, I got 16276, blah, 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 blah. When I worked that out, it came out as 1.63 times 10 to the 9, and that's how I presented it. Okay. Similarly for log t. Now this log, to be clear, is log to the base 10. We can see that because, if you notice here, we take log to the base 10 of this number, we're going to get the exponent here, we're going to get a 12. So all of this is log to the base 10, and again, all you're going to do is put in your values. Log t is log of 6.9 times 10 to the 3. We're going to get 3.838, 3.84 to 3 significant figures. Notice the question doesn't tell you to do 3 significant figures, you have to do 3 significant figures. You have to observe that and remember that that's what you've got to do. I think all things being equal, those are 2 quite nice marks to get. Remember that is 10% of your paper. The reason for those being nice is because of this bit. Okay, now the analysis here is pretty tricky, and I just think that a lot of students are going to struggle with this, and I noticed this when we were discussing it with students. Okay, what we're going to do is we're going to plot a graph of log and log. Okay, log of L over R squared on the y-axis, log of t on the x-axis. Now, we're being asked to explain how the gradient of this line, 3.99, notice it's almost 4, relates to the Stefan-Boltzmann law. Now, Stefan-Boltzmann law gives you L equals sigma a t to the 4. Now, in the mark scheme, it asks you to manipulate the law. And so I'm going to manipulate the law right now just to sort of explain what they mean by that. I'm just going to move this over so we can see it fully. Okay, let's start with it. And this is a lot of work for 2 marks. Notice that you got 2 marks in the previous question for filling in numbers, or calculating and filling in numbers. So the marks in paper 1B are really badly distributed, I would say. We know this is a straight line for a start, okay, and we're going to compare that straight line to our Stefan-Boltzmann law. We're first going to use the law, and we're going to recognize that it has a radius r squared, a radius r, and our area is 4 pi r squared. We're going to rearrange this. We've got L over R squared equals sigma 4 pi t to the 4. We're then going to take log of that. Log of the left-hand side equals log of the right-hand side, recognizing that log A times B equals log A plus log B. So we've got log A, our A is sigma 4 pi, sorry about my handwriting, that's my bad. Log sigma 4 pi plus log t to the 4. Now why have I separated it out like that? Well, because this log t is what's on the x-axis, and we can bring that 4 down to the front because it's an exponent. So we then end up with 4 log t plus log 4 pi sigma, or sigma 4 pi. Now you notice that the gradient should be 4. Okay, you'll notice that the gradient of this line should be 4, and it's roughly equal to 3.99. Now I realize I've actually not even answered the question. I've got so distracted by the first bit with the manipulation that the gradient equals 4. So, but this is what it should be. This gradient should be the exponent of t. It should be the power to which t is raised in order for this law to work. Okay, so let's imagine it was a law you didn't know, okay, and your gradient was 3. Then that would suggest that we go with t to the 3. If it was a 2, then that would suggest that it goes with t to the 2. If it was a 0.5, it would suggest that it's a square root dependence. So this analysis using logs is actually very, very powerful. However, it's something we don't do a lot, and I think it's a really unfair one for students. However, it's one that's in the paper, so we need to be kind of semi-prepared for this. If you're in doubt, take the log, bring the power down to the front, and that should tell you what that power is. And notice there we've got y equal mx plus c, okay, for x is log t, we've got 4 equal to m, and that's roughly right, 4 equals 3.99. Okay? Now, the next bit of the question relates to c, okay, I'm just going to come down here and quickly rotate this guy around. Okay, so in this case, we're being asked to determine the value of the Boltzmann constant. Now, if you've been asked about gradients, then you'll also be asked about y-intercepts. We saw in the previous that c, the y-intercept, is equal to 4 pi, log to the base 10 of 4 pi sigma. What that means then, and again, this really depends on how comfortable you are with logs, all right? What it means is that if I raise both sides, 10 to the power of both sides, so if I take this and raise 10 to the power of log 4 pi sigma, I get 4 pi sigma, I get 10 to the c. I know that c is minus 6.15. That means I'm going to have sigma equal to 10 to the minus 6.15 divided by 4 pi equals 5.63 times 10 to the minus 8. Now, if you go into your data booklet and you find 5.67 times 10 to the minus 8, you'll notice that it's very accurate. Okay, and so a conclusion for the investigation is that the experiment was accurate because our sigma value is within 10%, it's well within 10% of the established value. Now, I appreciate you may not have been able to get to that sigma value without doing this horrible analysis. However, as ever, there's always a nice bit at the end, okay, which talks to you about possible improvements. Now, it actually really is an open goal, this one, because they really are trying to get you a mark. I think they've recognised this as a hard question. Suggests a possible improvement of the investigation related to the range. Well, the range is incredibly small for, in the case of a planet, you're going, in terms of orders of magnitude, we are not actually using as wide a range as we could, and so we need to suggest using a wider range. As you know, when you do an experiment, you use the widest range possible, okay, and so they need to use bigger ranges to verify that that law is valid. I completely appreciate that this is a hard question. I think I've seen a lot of students battle over this and kind of give up when they're doing it. I really do hope that they don't have logs in there. I wouldn't spend hours searching up logs. However, having 2 minutes, just look at it, or talk to a friend about it just to make sure you understand the basics of it would be a very nice thing to do indeed. As I say, fingers crossed that they go for some more sensible analysis in your exam in the next couple of days.